Welcome to CO556 Network Systems. This is Chapter 2 of the Cisco syllabus. Switching concepts. The objectives for this week are to look at switching concepts. We'll explain how Layer 2 switches forward data. We'll look at frame forwarding and explain how frames are forwarded in a switch network. And look at switching domains. Compare a collision domain to a broadcast domain. Frame forwarding. Frame forwarding, switching in a networking. Two terms are associated with frames entering or leaving an interface. Ingress, entering an interface. Egress, exiting the interface. A switch forwards based on the ingress interface and the destination MAC address. A switch uses its MAC address table to make forwarding decisions. Note, a switch will never allow traffic to be forwarded out of the interface it receives the traffic on. You can see a simplified version of the MAC address table in the diagram presented here. Destination addresses, MAC addresses, are shown on the left-hand side, and then the port numbers that they are associated with. The switch MAC address table. A switch will use the destination MAC address to determine the egress interface. Before a switch can make this decision, it must learn what interface the destination is located. A switch builds a MAC address table, also known as a Content Addressable Memory, CAM table, by recording the source MAC address into the table along with the port it was received on. The switch learn and forward method. The switch uses a two-step process. Step 1, learn. Examines source addresses. It adds the source MAC address if it's not already in the table. It resets the timeout setting back to 5 minutes if source is in the table. Step 2, forwarding. Examines destination address. If the destination MAC address is in the MAC address table, it is forwarded out of the specified port. If a destination MAC is not in the table, it is flooded out of all interfaces except the one it was received on. Switch forwarding methods. Switches use software on application-specific integrated circuits, ASICs, to make very quick decisions. A switch will use one of two methods to make forwarding decisions after it receives a frame. Store and forward switching receives the entire frame and ensures the frame is valid. Store and forward switching is Cisco's preferred switching method. Cut-through switching forwards the frame immediately after determining the destination MAC address of an incoming frame and the egress port. Store and forward switching. Store and forward switching has two primary characteristics. Error checking. The switch will check the frame check sequence, FCS, for CRC errors, cyclic redundancy checks errors. Bad frames will be discarded. Buffering. The ingress interface will buffer the frame while it checks the FCS. This also allows the switch to adjust to a potential difference in speeds between the ingress and egress ports. Cut-through switching. Cut-through forwards the frame immediately after determining the destination MAC address. Fragment, free method will check the destination and ensure that the frame is at least 64 bytes. This will eliminate runts. Concepts of cut-through switching is appropriate for switches needing latency to be under 10 microseconds. Does not check the FCS, so it can propagate errors. May lead to bandwidth issues if the switch propagates too many errors. Cannot support ports with differing speeds going from ingress to egress. Switching domains. Collision domains. Switches eliminate collision domains and reduce congestion. When there is full duplex on the link, the collision domains are eliminated. When there is one or more devices in half duplex, there will now be a collision domain. There will now be contention for the bandwidth. Collisions are also possible. Most devices, including Cisco and Microsoft, use auto-negation as the default setting for duplex and speed. Broadcast domains. A broadcast domain extends across all Layer 1 or Layer 2 devices on a LAN. Only a Layer 3 device, a router, will break the broadcast domain, also called a MAC broadcast domain. The broadcast domain consists of all devices on the LAN that receive the broadcast traffic. When the Layer 2 switch receives the broadcast, it will flood it out of all interfaces except for the ingress interface. Too many broadcasts may cause too much congestion and poor network performance. Increasing devices at Layer 1 or Layer 2 will cause the broadcast domain to expand. Alleviated network congestion. Switches use the MAC address table and full duplex to eliminate collisions and avoid congestion. Features of the switch that alleviate congestion are as follows. Fast port speeds. Depending on the model, switches may have up to 100 gigabits per second port speeds. Fast internal switching. This uses fast internal bus or shared memory to improve performance. Large frame buffers. This allows for the temporary storage while processing large quantities of frames. High port density. This provides many ports for devices to be connected to LAN with less cost. This also provides for more local traffic with less congestion. What did we learn in this short module? Frame forwarding. Ingress is the entry port, egress is the exit port. The switch builds a MAC address table to forward frames onto the LAN. The switch can use either the store and forward or cut-through method of switch forwarding. Switching domains. Ethernet ports in half duplex will be a part of a collision domain. Full duplex will eliminate collision domains. A switch will flood out all interfaces except the ingress port if the frame is a broadcast or if the unicast destination MAC address is unknown. Broadcast domains may be broken up by a Layer 3 device like a router. Switches extend broadcast domains but can eliminate collision domains and relieve congestion. Some new terms and commands. Content accessible memory, the CAM table, also known as the MAC address table. Store and forward switching, cut-through switching, automatic buffering, fragment-free switching, collision domains, broadcast domains.